All right, good afternoon, everybody. It's 1 o'clock, so I just wanted to get class started. Hopefully some more people will hop in as we get going here. But how's everyone doing? Everybody having an okay day so far? Yeah, I'm having an okay day. Not a great day, not a good day, just an okay day. I'm tired too, I hear you. Okay, so first off, what I want to do today is I'm going to split the class up into two different like sections. So for the first hour of class today, I want to pick up where we were last class. So if you remember last class, we were talking about this binomial probability distribution, and we did one LeBron James example. Does that ring a bell? We were talking about free throws at the end of class. Okay. Yeah, I just want to do a couple more examples of those, okay, just so we have that ironed out. Then what I want to do is I want to then take any homework questions. So let me get through the binomial, and then I'll take any homework questions that people have for homework number 3. I'll help you work through any of them. And then we'll do a little bit of a review. I'll kind of like tell you about the important types of problems that'll be on the exam, and I'll do a couple examples. One last thing, under course content, if you scroll to week 7, I posted a sample exam that I gave last fall on probability, so you can just kind of see the type of questions I'm going to ask. Unfortunately, the exam this time is going to be just like it was last time. You're going to log into class, you're going to click on the exams tab, and there'll be the exam number 2 here for you. Okay. I'll try to, because it's an online exam, I'll try to put like more multiple choice in there, stuff like that, instead of just, straight plug in the numbers. Okay. But before I get started, does anybody have any questions just about the exam in general? No questions? I think it's going to be about 20 questions. 20 to 25, maybe 30 tops. So it's open notes, same deal as last time. So what I'll do is I'll start class, I'll log in, and I'll stay on Zoom the entire time in case there's questions. Like, I don't know if you guys remember last exam, I had a little bit of a typo. I had a repeat question, and then some people had like formatting questions. So, the Zoom will be there for you. Okay. All right, any other questions before I get started? No question? Okay. I'm tired too. I'll just tell you a story before we get started. Did anybody know that it is Prime Day on Amazon? Anybody pay attention to that? Yeah, so like all the other big companies like Best Buy and Target and Walmart are doing sales today too. So like, my son got me up last night around like 2 a.m. He was just, whatever reason, but I couldn't go back to sleep. So I went online and bought myself a laptop. So, I don't know if that's a good thing or bad thing, but just be careful of impulse buying at 2 a.m. because then you might end up with a laptop. Yes. The things I've bought off the internet in the middle of the night when my son wakes me up. All right. Just thought I'd make you laugh before we get started. Understand the 3 questions on 9. Yeah, so on the homework you're talking about? Yeah, so question number 9. The counting questions right here. I'll buy a car next. Is these the question number 9 you're having a hard time with in the chat? I'm going to go over these counting methods Okay, you mean the last one? Just this one right here? The number of computer passwords. I'll do an example that's just like it, okay? When we get to review. All right, I promise you. And then after I do the review, that'll ease that one up for you. I promise. I won't leave you hanging dry with the time we have in class. Okay. So let me just get through this. How many people have their graphing calculator on them today? Okay, take out your graphing calculator. It doesn't matter if you have a TI-83 or TI-84. Okay, we're going to use both. I'll show you how to do these problems both ways today. So what I want to do is I want to set up a problem and I want to show you how to do it longhand first, just so you have a full understanding of what's going on. And then I want to show you how to use your graphing calculator a little bit for this, okay? Okay, so just a quick review. Last class we were talking about the binomial probability distribution. Okay. And what the binomial probability distribution is used for, it's used to compute probabilities for binomial experiments. Okay, so what the heck is a binomial experiment? A binomial experiment needs to have 4 criteria. One, it's performed a fixed number of times. Just out of curiosity, does anybody remember what we called each repetition? It started with T.
A trial.
Thank you very much. Yep. Does anybody remember how many outcomes there has to be for each trial? Yep, thank you in the chat. Has only 2 outcomes. We call those outcomes a success or a failure. Each trial is independent. And then the 4th one is the probability of success never changes. Okay. So then we had this formula, okay, going back. I'll come back to this slide in a second. But we had this formula here, okay? And it was probability that the number of successes is equal to some number, okay? And this will be like x is equal to 2 or x is equal to 3, whatever, all right? It was just n choose x times p to the x power times 1 minus p, oops, sorry about that, 1 minus p raised to the n minus x power, okay? N is equal to the number of trials. X is equal to the number of successes. Does anybody remember what n minus x has to be equal to then? Not the number of successes, but the number of, yep, thank you in the chat, appreciate that. P was the probability of success. And then by extension, 1 minus p is the probability of failure. Yes, Leonardo, we're going to do that after I get through this. We'll do it during the second half of class. Okay. But also this also kind of serves as a review for your exam because you're going to get a question just like this on the exam, okay? All right, so I think at the end of class, we were able to just do one example of this, right? We just did the probability LeBron James makes exactly 8 free throws in 10, right? So I want to do another example of this, okay? I'm actually going to do 2, okay? So that this will hit home for you. But is everybody okay if I move on to the next slide? I got 1 yes. Okay. Example 1, let's do this one. Have you guys heard of this over-the-counter medicine called Claritin D? Has anyone ever heard of it? Yeah, what is it? What is Claritin D used for? Everyone's heard of it. Yeah, okay. So any over-the-counter medication you take, well, not everyone, but most of them, I can't even say most of them. Some over-the-counter medicines that you take have adverse side effects, okay? So I used to take, I get real bad allergies. I don't know if you guys ever hear me like sniffling during class. I used to take Claritin D, and I don't take Claritin D anymore because I used to get an adverse side effect when I used to take it. And it's actually one of the more common ones. So let me talk about that, okay? So Claritin D is, I only ask because I feel like we've had so many days of probability lectures. I'm kind of fogged on with the lecture. Yeah, I'm going to go over that, Leonardo. You have nothing to worry about. It's going to be a ton of probability questions. I'm going to go over everything if you just let me get through this. I promise. I'm not going to leave you hanging. Okay. Claritin D is used for allergies. And according to research, right, 5% of people who use Claritin D, all right, experience insomnia. And that's why I don't actually take it. All right, this is a common side effect of Claritin D, okay? So suppose 20 Claritin D users are selected and we record the number of people who experience insomnia. Okay, so let me just kind of go through this in a little bit more detail. I'm going to talk to 20 people, okay, who take Claritin D, okay? You know, it can even be an experiment. I'm going to give 20 people Claritin D. And all I'm going to do is at the end of them taking Claritin D, like the next day, I'm going to say, hey, did you experience insomnia? Okay. Make sense? So let me ask you this. Do I know how many people of the 20, do I know exactly how many people of the 20 will experience insomnia? Yeah, like I don't, right? Thank you in the chat. I have no idea. Okay, so it's a random outcome. So it's a random variable. So I'm going to define a random variable. I'm going to let X be equal to the number of people who experience insomnia. All right, just out of curiosity, what are the possible values of X? Like, what's the least amount of people who can experience insomnia? You're close. It's not 1 to 20. You're missing. Yeah, thank you. The least amount. So just so we're clear, you would expect 2 of the 20. Okay, just so we're clear. But that's different from the total number. All right. You could have 0 Out of the 20 experience insomnia, you could have 1, you could have 2, you could have 3, you could have 4, and you would keep going all the way to, you could have 19 people, and you could literally have all 20 people in the study experience insomnia. Okay? So just out of curiosity, is this random variable here discrete or continuous? Well, it's discrete because there's a finite number of things that could happen. Okay, there's a finite number of things that could happen. All right, the next question, okay, is this a binomial experiment? Okay, so there's 4 things you have to meet, okay, just so we're clear. Is this performed a fixed number of times? Like, how many people are we talking to? Yeah, okay, so yeah, we're talking to 20 people. That's it, it's fixed. There's exactly 20 people. Yes. All right, are there only 2 outcomes for what we're tracking? Okay, so there's 2 outcomes. There's what's considered a success and there's a failure. So since we're counting, this is weird. Is it a good thing or bad thing to experience insomnia? It's a bad thing. I hate insomnia. I don't know how many people ever experience insomnia. I'm groggy the whole day. I've got to have a second pot of coffee. It's terrible, okay? But for this problem, since we're counting the number of people who experience insomnia, that's what we consider. I always like to do this. I'm just going to turn my video on for a second. Can you guys all see me? This is why it's called a success. Like, I always put it in quotations. It's a success, okay? So a success is the number of things you're counting, okay? So a success here would be that the person experiences insomnia. And a failure would be the person sleeps well. Okay. The third criteria is the trials are independent. Okay, meaning if I experience insomnia, does that have any impact on if somebody else in the study experienced insomnia? Yeah, so exactly, no, it doesn't. So yes, they're independent. And this right here, this is the probability somebody experiences insomnia. Okay, so that's our success. Never changes. And that stays, yes, okay? All right, so this is a binomial experiment. So basically what's gonna happen next is I'm gonna ask you a problem that requires that binomial probability distribution formula, okay? Is everybody okay if I go to the next slide to ask the question? Okay. Okay, so we're still on the Clarendon D. So here's the first question. What's the probability that exactly 2 of the 20 experience insomnia? Okay. So remember, if it's a binomial experiment, it's always this formula here. Probability x is equal to x is equal to n choose x times p to the x times 1 minus p to the n minus x, okay? All right, so if I want 2 people to experience insomnia, how many successes do I want? So I want exactly 2. Okay, so I want 2 people to experience insomnia, okay? So I want to find the probability that exactly 2 of the 20 experience insomnia, okay? Sometimes it helps to do this, okay, just so we're clear. How many trials are there for this experiment? Like, how many people are we talking to? Okay, yep, 20, perfect, perfect. I want 2 people. I'm counting the people who experience insomnia. I want it to be 2. Okay, how many people do I want to not experience insomnia then? Thank you, yeah. What's the probability somebody experiences insomnia? If you look back here, what is it? Thank you, yeah. What's the probability then that someone gets a real good night's sleep? What's 1 minus this? Thank you, yeah. So I honestly think that sometimes that's the hardest part, because now once you have that, okay, it's just plug into the formula and go, okay? So it's n choose x, so it's 20 choose 2 times the probability of success, 0.05 raised to the number of successes, which is 2, times the probability of failure, which is 0.95, raised to the number of failures, n minus x, which is 18. Okay. All right, so at this point, once you have it set up, you just got to grab your calculator. You got to grab your trusty calculator that never lets you down, okay? So it doesn't matter which calculator you're going to do this in, okay? I'm going to grab my TI-84 here, okay? How many people see it on the screen here? Okay, I got 1 person who says yes. All right, good, good, good. Okay, so the first thing you have to do is you have to figure out what 20 choose 2 is, okay? So you start by typing 20. You press the math button. If you have the TI-83, you're looking for PRB. If you have the TI-84, you just scroll over to PROB. You go down to number 3. And then type in the next number, 2, okay? So how many people got that right there? Anybody else? Oh, good, okay, thank you, okay. So that's just this first part, 20 choose 2. Now you need to multiply it by 0.05 squared. So you're gonna hit times 0.05 squared. You're gonna get that number right there. Then you need to multiply that by 0.95 to the 18th power. So hit times 0.95 raised right here to the 18th power. How many people got that answer right there? Okay, great, great. It's like, yes, success. Okay, here, I'll cheer us on, okay? You can see my video again. It's a success, we got it, okay? I'm glad you found that funny. All right, so I'm just gonna round this to 4 decimal places. It's 0.1887, okay? Just like that, okay? So let me ask you this before I move on real quick. Is the Is the formula not too bad? It's just maybe kind of figuring out exactly what's being asked. Yeah, I understand. I understand. Okay. I'll tell you this, okay? On your exam, what I'm gonna do to help you out. You ever notice on the last exam when you come to a problem, like there's a title, there was a title for the problem? I don't know if you guys remember that on the last exam. Okay. Maybe when you come to a problem and it says the binomial experiment, you'll know to use this formula, you know? Or if I say general multiplication rule, you'll know to use that formula, okay? So just pay attention to problems that have titles to them, okay? So I'm trying to throw you a bone on this one, okay? All right, let me ask you a follow-up question to this. Okay, still sticking with the Claritin D. What's the probability that 2 or less experience insomnia? Okay. So this problem we did exactly 2. Now we want 2 or less. 2 or less. Okay. Does anybody have a suggestion for how we can solve this? What outcomes, and I'll go back for a second. I'm sorry if I'm going too fast, but I just want to go back and show this. These were the possible outcomes, okay? What values are 2 or less? Yeah, there's 3 total outcomes for this. You can have, listen to how I say this, okay? You could have 0 people experience insomnia, or you could have 1 person experience insomnia, or you can have 2 people experience insomnia, okay? Daniela has it right there in the chat, okay? So it's the probability that 0 people experience insomnia, or 1 person experiences insomnia, or 2 people experience insomnia. When you see the or statement, what mathematical operator and probability, thank you. Yep, it implies add. So you're gonna find the probability that 0 people experience insomnia, add to it the probability 1 person experiences insomnia, and add to it the probability that 2 people. Good news, bad news. Let's start with good news first. Do we know the probability that x is equal to 2? Did we already do that? Yeah, if you look back one slide or in your notes, if you're taking them, we did it right here. It's 0.1887, boom, right there. So that goes right here. That's the good news. What's the bad news? Yeah, unfortunately you have to find the rest, I'm sorry, okay? So this is important. In these multi-step problems, okay, I'm just gonna go back a slide. The only thing that ever changes is the x, this x, and then n minus x. Everything else stays the same, okay? So just remember, just recall the formula is always, always, always. It's n choose x times p to the x times 1 minus p to the n minus x. All right, so down here, let's do the probability that x is equal to 0. All right, how many trials are there to this experiment? That's yep, thank you. Yeah, you got it. It's 20, right? So we're gonna talk to 20 people, and now we wanna choose 0 of them to experience insomnia. So then I wanna multiply the probability of success, so 5% of people experience insomnia, raised to the number of successes, which is 0, times the probability of failure, which is 0.95, raised to the number of failures. So n minus x, 20 minus 0 is 20. All right, I'll help you out on this one. 20 choose 0 is 1. Does anybody know what 0.05 raised to the 0 power is? Yep, it's 1. Anything raised to 0 power is 1. So it's 1 times, so really you only have to do 0.95 to the 20th power. And you should get 0.3585 when I round it. Okay. Now the next thing, you got to find x is equal to 1. Okay. So I want 1 success. So it's 20 choose 1 times 0.05 raised to what power? Okay. Times 0.95 raised to what power? Thank you. All right, let's grab our trusty calculator. Okay. So the first thing you got to do is 20 choose 1. Come back. So you're going to go 20, then math. You're going to go over to PROB right here. And you should get 20. Then you need to multiply this by 0.05 raised to the 1 power. So just multiply by 0.05. And then you need to multiply this by 0.95 raised to the 19th power. How many people got this if you were following along? Awesome, awesome, thank you. So it's 0.3774 when I round it. Okay, so now I just have to put these in here. It was 0.3585 plus 0.3774 plus this. Let's see what we get. 0.3585 plus 0.3774 plus 0.1887. Awesome. How many people got this? Okay. Awesome. Awesome. So the probability that 2 or less experience insomnia is 0.9246. And that's our final answer right here. All right, not too bad, or like, I can't tell. It's hard over Zoom. All right, you guys, want me to show you a much easier way to solve these now? Yeah, please. All right, I understand it's still a bit confusing. So I'm going to show you a much easier way, okay? Do you guys remember when we were doing regression and I said, this is how you find a regression by hand? And then I was like, oh, you know what, just by the way, your calculator does it for you. It's kind of the same here. Your calculator, a lot of times in this class, okay, actually like every time in this class, when we get to a new concept, I'm going to show you like, hey, you know, this is how you do it by hand, but you know what, your calculator has a built-in function, okay? I'll talk about the timing in a second. Let me show you your calculator now, okay? So this is the Claritin D example with calculator. Okay. So what was the first question I asked? The probability of exactly 2? Okay. You guys hear my little one waking up in the background? Yeah, unfortunately nap time is ending. Okay. So everybody take out your calculator, okay? And I'm gonna show you how to do this on both the TI-83 and the TI-84 because they're slightly different, okay? You guys, everyone see both calculators? Okay, so there's this button on your calculator, okay? It's called DISTR. Do you guys see that on both the TI-83 and the TI-84 right there? DISTR, DISTR. All right, so to get to it, what you're gonna have to do is you're gonna have to press second function, DISTR. Over here, it's the same thing, second function, DISTR. We're gonna use this distribution button a lot, okay? So what this is showing us is that it's showing different probability distributions. So if you scroll down, you should see two things called the Binompdf and the Binom Cdf on both calculators. Do you guys see them? Okay. We're gonna need both of them, all right? So for probabilities that say exactly, okay, I want exactly this number. You want this first one, Binompdf, okay? So everybody go slowly. Everybody go to Binompdf and hit enter, okay? So you'll notice a subtle difference on the calculator. Unfortunately, if you have a TI-84, it makes it a lot easier. If it's a TI-83, you're just gonna have to remember this. Okay, yeah, sure. What type of calculator do you have, first off? And I'll just do it on that one. 83 or 84? 83, okay, so over here. All you do is you go to second function, DISTR, and you scroll down until you find Binompdf, okay? Are you good? Okay. All right, so I'm gonna go back to the slides for a second. So for probabilities that involve the word exactly, you're gonna use this function called Binompdf. All right, and there's 3 things you have to plug into it, okay? The first thing it says is the number of trials, okay? So the number of trials was the N number. So how many people did we talk to for this example? Okay, so you're gonna put 20 there. If you have the TI-83, which unfortunately what you have to do is you have to type in, freaking thing. It's a terrible emulator, sorry. It bugs out all the time. You have to type in 20, okay? And then you have to press comma, so 20 comma. The next thing is the probability of success, P, okay? So what was the probability somebody experienced insomnia? All right, so you have to write it as a decimal, okay, just so we're clear. So over here, you have to put in 0.05 and then press comma. And then the X value is the number of successes. Okay, how many people did we exactly want to experience insomnia? You're just gonna put 2, paste. Over here, you just have to put the number 2 and then close the parentheses, okay? And now let's hit enter. How many people see what I have on the screen there? Okay, guess what? Was that the answer that we got when we did it by hand? 0.1, Yes. I should lead with this every time. So it's a lot easier. So let me just go through exactly what you need to plug into your calculator, okay? The first thing you're always going to put in is n, which was 20. The second thing you're always going to put in, which is p, is the probability of success, okay? And then the last thing you're going to put in is x. So much easier, okay? Now the next question says, what was the probability of 2 or less? Okay, 2 or less. Do you see how I'm writing this as less than or equal to 2? Okay, is that the same thing as 2 or less for this problem? Okay, you have to be careful, okay? Because I might ask you the question this way, okay? What's the probability of less than 3? Okay, less than 3 would be 2 or less. So you just have to, you have to know exactly what the first, what the ending value is, okay? So for 2 or less, it's exactly this number here. So for this one, whenever I want to do a 2 or less, okay? So 2 and then everything less than this. The other option was this Binom Cdf, okay? So everybody go back to their distribution button and scroll down now till you see Binom Cdf, okay? Binom Cdf. You're gonna notice it's gonna say the same exact thing, okay? So the number of trials, how many trials are there for this? It's still 20. So you're gonna put 20 here. And the TI-83, you have to go 20 and then comma. Probability of success is 0.05, that doesn't change. 0.05, comma. Now the X value is really important. It's the highest value you stop at, okay? So notice how I go all the way up to 2, all right? I want 2 or less, okay? So I'm gonna put 2 here. I'm gonna paste over here, I'm gonna put 2 and then close the parentheses. Now watch what happens when I press enter. So here we got 0.9245. I think we got 0.9246, okay? The reason we're off just a little bit is because we rounded all the values in the previous example. So this is the actual correct one, okay? So is this a little bit easier than what we were just doing? $0.9245, I'm just gonna put down there. So again, it was 20, 0.05, and then 2. So it's N, then you put in P, and then you put in the top X value. So if you use these commands, do you just like legit see how easy this is? It can be. I think so. Okay. So I'm just gonna, can I just do real quick one more problem for you? And we'll just use our calculator before our break, and you'll see how quickly these can go once you recognize the problem. Sound okay? I got one yes. Any others? Okay. Everybody okay if I move on to the next page? Okay. And this will be another binomial experiment. According to the Department of Education, now I'm totally not making this up on the spot. This is an absolute true statistic. So according to the Department of Education, 90% of college students love taking statistics. What do you guys think of that? True? True or not true? You know what? I actually am surprised by this number. Is anybody else surprised by this number? I'm surprised because I think it's actually too low. I mean, obviously more people love taking statistics, okay? I mean, yeah, I'm surprised too. Me? Biased? Never, okay? Oh, come on, everybody. I hope I make this class somewhat enjoyable, you know? You know, I try to sprinkle in some humor, you know, but I know I can only imagine that there's a bunch of people eye rolling on the other side of this, okay? You know what, it's okay, it's cool. It's cool, I understand. I hope it's enjoyable, you know? You know, if you guys throw me a bone a little bit in the chat, you might get an easier exam. I don't know. I'm just, you know, throwing that out there. That was a joke. That was a joke, by the way. Okay. I promise you, just a quick sidebar. First off, I understand probability is not the most fun. Okay, I get it. I've been teaching this class for like 12 years. Probability is one of the hardest parts because it's a little bit, the problems are a little nebulous, like what problems you use. So I understand. All right, but anyways, let's just get this problem done. Suppose, well, let's say 10 college students are selected and the number who love taking statistics is recorded. Okay. So I got 3 questions for you, okay? And then you can see that your calculator will do all these in a matter of minutes, and then I hope you'll be ready for the exam. Okay, what's the probability exactly 9 love taking statistics? Actually, let's change it. Let's probably exactly 8. Okay, exactly 8. All right, so this is a binomial experiment, okay? Because there's only 2 things that can happen, right? You either love taking statistics or you don't. Probability of success never changes. If I love taking statistics, it has no bearing on if you do. And it's performed a fixed number of times because we're talking to 10 students, all right? So it's the probability that X is equal to 8. All right, so going back for exactly probabilities, is it a Binompdf or a Binom Cdf that we use for this? Okay. All right, so the first thing that goes in is the number of trials, okay? How many college students are we talking to? So it's going to be 10. And then what's the probability that they love taking statistics? That comes in last. So the next thing is the probability of success. Yeah. And then you put how many you want. And I want exactly 8. Okay. So I'll just load it up on this one here. Okay. Because of the TI-84, it's pretty easy. So second function distribution. I want the Binom PDF. I'm going to talk to 10 students. Probability that they love taking statistics is 90%, which is way low, I agree. And I want exactly 8 of them. How many people get this on their calculator? All right, so if you use your calculator, is it pretty straightforward? Do you think you could handle this? Okay, where do you go to get the Binom PDF? No problem. Mal, do you have an 83 or 84? Yeah, okay, so you hit second function, and then do you see this distr here? And then you're gonna scroll down. You have to scroll down till you see Binom PDF right here. You got it? Yep. Yeah, of course you can. Yeah, and then you just the same thing. So it's 1937.
How do you do it for the 84 again?
Yeah, so the 84, you just go second function distribution. And then you scroll down. Do you see Binom PDF? And then the good news is that it asks you like right there, you know, it makes it so much easier to input in stuff, you know, and you get the same thing. Okay.
Yeah.
Okay, here's the next question. Now be very careful how I write this, okay? Read this. What's the probability that less than 8 love taking statistics? Okay. So it's less than 8. It's a strict inequality. It's a strict inequality. So you just have to be careful here. For strict inequalities, you're not, I want to rewrite it some way. If I want to be less than 8, is it the same thing as being less than or equal to what number? Yeah, you just have to be careful, okay? If I say less than or equal to 8, then you can have the equal sign under it, okay? But the reason you need this here is for when now we're going to use the Binom Cdf, okay? So it's going to be the same exact options. You're going to put in the number of trials, the probability of success, and then the stopping value, okay? So we don't stop at 8 here because I want you to be strictly less than 8. So we stop at 7. So I'm going to grab the TI-83 again. So it's second function distribution. Binom Cdf right here, Binom Cdf. And it's 10, 0.90, 7. And then close the parentheses. And how many people get this?
Yeah,
so,
I got that.
Good, right? Not so much easier with the calculator?
Yeah.
Like night and day, right? So I'm just gonna round this to 0.07, okay?
Very way easier.
I'm sorry? Way easier, yes. Okay, last question for this. What's the probability that 8 or more love taking stats? Okay, so 8 or more, you could do this the hard way, I guess, and this would be the hard way. You could do 8 or 9 or all 10, okay? But can anybody offer me an easier way real quick using maybe the complement rule? What's the complement of 8 or more? So it does include 0, but so if I want all the options that are 8 or more, the complement of it is 7 or less. Which we just found right here. Just like that. Okay. But you could also solve this by doing the Binom PDF 3 times for like 8, for 9, and for 10, and then adding them together. But I just thought I'd throw this one out there. Okay. Think you could handle questions like this and this on the exam? I love that response. Sure. Okay. Let's turn on my video. Let's just take a just a 5-minute break, just to cool our jets and you know. So the last one here, if you're looking at it, so just the opposite or the complement of 8 or more is 7 or less. Like the complement of like anything or more, the complement of it is less than that number. So that, I mean, that's how I got it. But you could also solve this if oh, okay, good. So what I want to do now is let's just take a 5-minute break, recharge our batteries, and then what we'll do is we'll come back and I'll do a review for you for the exam on Thursday. We'll talk more about it, okay? Okay, so. It's let's start back at 2:03, okay? So I'll be back on the call. I'll be back on Zoom at 2:03. Sound good? Okay, can everybody can hear me okay? All right, so just before we start, let me just say just a few things. Like, of all the exams you'll take in this course, this one tends to be the hardest. So I get that, and I get that it's online, and I get that it's remote. So I'm going to try to make the online exam more straightforward for you. I'll do my best. I'm still putting it together. It actually takes a while to like write the exam in Blackboard because it's just not the easiest thing. So I will get on that, but there's nothing going to be super tricky on it. Okay. If you do look in the classroom and you look at under course content, if you do look at the sample exam, that's a great way to study. And then I actually think the homework's like, honestly, the homework homework's probably harder than the exam itself. So if you can handle the homework, you're going to be okay. All right. So before I get started with the review, does anybody have any just final specific questions? And I'll answer some questions that will help with the homework, but let me get through the review first. Does anybody have any questions about any of this or the exam structure again, real quick? No question. On the homework, the first question on the homework. Okay, so do first question on the homework. Let me just help maybe like with the sample space, right? Like once you figure out the sample space, got to put my phone on silent there. Once you figure out the sample space, it's not too bad. Would you agree with that one? Okay. Right, so homework number one, question one. All right, so you flip a coin. Four times in a row. And record your result. All right, so even before I begin, does anybody know how many total number of outcomes there are for this? Each coin flip, yeah, so each coin flip has 2 outcomes, but there's 16 total outcomes because you're going to flip a coin 4 times. So like, maybe with my video you can see. So the first coin flip, yeah, there's 2 outcomes, and then there's 2 outcomes for the second coin flip, 2 outcomes for the third, 2 outcomes for the fourth. 2 times 2 times 2 times 2 will get you 16. Yeah. All right, so now you just have to figure out the total number of outcomes, or what all the different outcomes are. So the easiest thing here to use is a tree diagram. So you're going to have your first flip. This is a little bit of a pain, okay? You can get a head or a tail. Then on your second flip, you can get a head or a tail. And then on your third flip, this is where it gets a little crazy. Yep, I'll do number 9 after this, no problem. And then, sorry about this, then you get your fourth flip. And then do you guys see, I know this is like a crazy tree, but do you see how each branch now represents the total possible outcomes? So all you have to do now is just like traverse the branches, right? So the sample space is H, 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 H. Then the next branch is H, 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 T. And then so on. H, H, T, H. H, H, T, T. And then you can go from here. So I forgot who asked the question, but now that you've seen me do the tree diagram, do you think getting the sample space from here and then answering the probability questions will be okay? Okay. Give it a shot. Give it a shot. This is a lot harder than the one that's on the exam, okay? So question number 9. Question number 9. Okay, so question number 9 involves accounting. So find the following. The number of ways the top 4 racers can finish a 20-person race. Just out of curiosity, in the chat, does anybody know what type of problem this is? It's a P-word problem. Yep. Thank you, Paulina. It's a permutations, right? So it's an N and R problem. Okay, so there's 20 people running the race, and you want to select the top 4. So in a race, does order matter? Yeah, it sure does, right? I want to be first. Okay. You guys ever? Oh, this is a bad joke, but I'm gonna tell it anyways. You guys know the Will Ferrell movie, Talladega Nights? It's a little old movie, but it's a kind of a hilarious movie. But there's a funny quote in it where he says, "If you're not first, you're last." So order matters here. So this is just 20 pick 4, and then you would plug that in your calculator, and you would get whatever that is. Okay. All right, so what was the next question? If 6, the number of ways you could select 6 students from 30 to serve on a review panel. All right. How many total students are there to pick from for this problem? Okay. But how many do I want to select? Okay. Does order matter or order not matter here? Yep. Order doesn't matter here because if you're picked first or you're picked 6th, you're still on the panel. Okay. So what type of problem is this? Yeah. So this is just 30 choose 6. And then you would just plug that into your calculator and go. Okay. All right, find the number of possible computer passwords that must begin with a number and are followed by 3 letters. Okay. So this is what the password must consist of. It must consist of a number, a letter. Yep, I'll do number 8 after, sure. Another letter, and then another letter. All right, this problem is a little vague because I didn't specify like the digits and if repeats are allowed. So let's just assume the numbers are the digits 0 through 9. And for the letters, okay, repeats are allowed. All right. So this is just a general multiplication rule question. or the the fundamental principle for counting. I have a task I need to complete. The task is I can't speak here. The task, it's a tongue twister. The task is picking the password, okay? And it consists of a sequence of options. So how many options do I have for the first number? Yeah. Does that say 6 to 9? 0 to 9, sorry. 0 to 9. And then how many letters are there in the English alphabet? Yep, so there's 26 options for the first letter, 26 for the second, and 26 for the third. So you would just multiply these together on your homework. Okay. So I forgot who asked the question, my apologies, but does this help for homework number 8 or number 9, I mean? It does? You asked it, Theo, thank you. I'm going to assume it does. Okay, great. Now somebody asked about homework question number 8, this one right here, this life expectancy one. Is this question? Okay. All right, so this is just asking like, this is poorly worded, but what I just wanted to ask, what was the expected value of this policy, actually to the insurance company. So, because that's how I did it in class. So I'm sorry about policyholder. So we're going to do this exactly like how I did it in class, okay? So, because you're going to get an insurance question just like this on the exam, okay? So a 23-year-old male pays $275 for a $150,000 life insurance policy. Okay, the probability the male will die before turning 24 is 0.001502. Okay. Okay, so he pays $275 for a $150,000 one-year term life insurance policy, and the probability he dies is 0.00001502. Okay, let's compute the expected value of the policy. Okay, so whenever you see the expected value, it was just this formula. It's the sum of each possible X value times their corresponding probability. Okay, do you guys remember that formula? We did like the expected value for a die roll, the expected value for the number of cups of coffee I have, yeah, okay, good. So we got to set up a nice little table here. So there's only 2 outcomes here, right, that we care about. It is that the person lives or they die, correct? Those are the only 2 outcomes we care about. Okay. So if the company, if he lives, how much money does the company make? Like, yeah, so he paid $275 for this policy. So the company makes $275. The probability he lives is just 1 minus this. I think it's 0.998498. Did I do that correctly in my head? Thank you. Okay, so the probability he dies is just that. So now you have to ask yourself this: how much money does the company lose? Okay, if he dies. Yeah, okay. So, you know, they will pay their beneficiary $150,000, but they've already gotten this much money from you. So exactly in the chat, thank you so much. They will lose minus $149,000 $725 because you have to subtract this 275 from this. So now the expected value is just 275 times this. Plus minus this. Times 0.001502. And then that's whatever, I'll let you guys work that out on your calculator. I don't know, it's like probably $50 or something like that. I don't know. Okay. Looks okay? What are you confused about? You can turn on your mic if it helps.
Is that a negative 149,000?
Yes, yes. Okay, so two parts here. First off, this is how much money the company loses if I die, right? Or if this 23-year-old person dies, right? Because they have to cut a check to the beneficiary for $150,000, but they kept $275. Okay, so they're really losing $275 that they got from you, minus the $150,000 that they had to cut a check for, which is how I got that negative value there. Does that make a little bit more sense where that comes from? And yes, it has to be negative in the calculations, okay?
I'm kind of confused.
Yeah.
Because the example that you did in class, you didn't put the negative in the calculation, so I'm not sure. The one that refers about maths and the insurance company.
Let's see. Right here, this problem? Yeah, there's the negative in it.
Oh, but you still got the okay.
Yeah, you're going to get a positive number at the end, but you definitely need that negative.
Okay.
And then to go back, where did the 0.998498 come from? Let me get to it. So the probability that someone lives is 1 minus the probability they die, which is 1 minus this number up here. Which is how you get. Does that help? Okay. All right, does anybody want to see me do any other homework problems real quick while we're here? All right, so all right, Emmanuel, I'm going to do a problem like number 6. Let me hop into the review because we only got about 30 minutes left. And I'll do a problem like number 6, okay? I promise. Okay. Okay, so first off, the exam's going to go in order of topics, okay? Homework is, you have until, Thursday night to turn it in, is what it's set to. Okay. All right, so these are the order your question's gonna get thrown at you. Okay, there's gonna be basic probability stuff. Okay, this is gonna be like the coin flip die roll question. Okay. I might ask something like, if you flip a coin 2 times, okay, what's the sample space? And record your results, okay? So this would be something like, well, if you flip a coin 2 times, how many total outcomes are there for this experiment? So your homework was you flip it 4 times in a row. Well, 2 times 2 is 4, so the outcomes would be you get a head and a head and a tail and a head, or a tail and a tail. And then I could ask, like, what's the probability at least one head? Well, there's 4 total outcomes, and 3 of them have at least one head. So there'd be a problem like this, okay? Very, very straightforward coin flip question. Right, then we started moving into the rules, okay? The first rule we did was the complement rule. Right, and that was just the probability of EC. The complement is equal to 1 minus the probability of E, okay? And the question like this might be, the probability a college student loves statistics. What did I say that probability was? Or what percentage did I say it was? Does anybody remember from earlier on? Yep. Okay. So the question might be, what's the probability a college student does not love statistics? It's just 1 minus the probability that they love statistics, which is 1 minus 0.90, which is 0.10. Okay. So like so far, are the questions okay? Pretty straightforward? Okay, I hope so. All right, I'm going to move on. Is everybody okay if I move on? Okay. The second rule we had was the general addition rule. Okay. I'm not going to ask you, if you remember the questions I did in class were like, what's probability to get a king or a spade? I'm not going to ask questions like that. This general addition rule is going to come up and it's going to actually be parts of later problems. And what I just mean by that is whenever you use an or statement, okay, what mathematical operator does that imply? Okay, it's just whenever you see an or statement, it's just addition. All right, then we had what was called the general multiplication rule for independent events. Okay. And let me give you an example of this, okay? Roughly 87% of the population is right-handed. I think that's about right. I don't think, I didn't just make that up. I think that's roughly what it is. I could be off a little bit, okay? If 5 people are selected at random, okay, what's the probability all 5 are right-handed? Okay. So I want to find the probability all 5 are right-handed. Do you guys remember doing problems like this? I think we did it was like a blood test one, and then we did the Challenger example, okay? And just as a quick sidebar, like a lot of people didn't remember what the Challenger disaster was or knew. There's actually a documentary on Netflix about it that's out if you're interested and have time this weekend, okay? So anyways, it's just the probability the first is right-handed and the second person is right-handed and the third is right-handed and the fourth is right-handed and the fifth is right-handed. All right, so when you see the and statement, okay, does anybody remember what mathematical operator the and statement? Yep, you multiply. Okay, so you just ask yourself now, are these independent events? Meaning, if I'm right-handed, does that have any impact on if you're right-handed? Yeah, no, yeah. So we know the probability somebody's right-handed is 0.87. So it's just 0.87 times 0.87 times 0.87, 5 times. So grabbing your trusty calculator. You get this, 0.4984. Okay. Think you could handle a question like this on the exam? I get 1 yes. All right. Just remember, okay, check what the title of the problem is, okay? When you see the question, check what the title is, okay? Like just going back, what I mean by that is, you know, like right up at the top, it's gonna have a title, okay? So the title is gonna kind of give away what the problem is, okay? All right, so just pay attention to those. Okay, then the next question. Sorry, I don't know if you guys hear the dinging of my email there. Let me just close it. Okay, let's go to the next type of question. Let's see, we were on rule D was the general multiplication rule. Oh, I'm sorry. Rule D was conditional probability. And this question will be, it'll look like a table. You'll have a table of data, okay? And just remember, if I ask you what's the probability of some event F given that event E occurs, it's just the number of ways that E and F can happen divided by the number of ways E can happen. All right, so let me just give you this example. Do you guys remember when we did the example about the Titanic in class? like it was like if a female is selected, you know, just suppose you have a sample of 200 students. Okay, and I have it broken down by male, female, and if they're a first year, or if they're a second year student, so a freshman or a sophomore, okay. And there were 20 male first years, 30 second years. There were 80, what is this? And 70 here, like this, okay? Whenever you get a table of data, what you should definitely do is find the sums, okay? So like there were 50 males, there were 150 female students, there were 100 first year students, and then there were 70, or 100, I'm sorry, second year students, and there were 200 total students. Okay, so a question might be like this, okay? If a female is selected, what's the probability she is a first year student? Okay, so it's just the probability of a first year given that a female is selected. All right, do you notice how, like, do you notice this words, if a female is selected? That's telling you to assume that a female is selected. So this is just the number of female first year students, which is 80, divided by the total number of female students, which is 150. And that's how you'll do like this conditional probability question. Okay, does this kind of ring a bell when we were doing like the Titanic stuff? Okay, and you got a chance to practice it on your homework too. You got a question like this on your homework. Okay. It does feel like it was 60 years ago, you know? It's 2020, something crazy happens every week, okay? You know? Literally March, the start of the lockdowns, feels like 150 years ago. It does, doesn't it? Isn't it crazy? Yeah. Okay, and then I believe somebody asked a question that was like question number 6, right? I'm sorry, I forgot who asked that. I'm going to ask you to put answers as a decimal. So you would take a decimal, so you would take 80 divided by 50. Or 80 divided by 150, I'm sorry. And then I would say round to 3 decimal places or something like that. Okay? All right, so then the last rule of probability we had was the general multiplication for dependent events. Okay. And this I'm going to do the first part of the homework question for you. Okay, so just so you can see. All right, so suppose you have a bag of marbles that contains 5 red marbles, 3 blue marbles, and 2 green marbles. Okay, if you draw 2 marbles in a row, one after the other, without replacing the first, what is the probability of getting 2 red marbles? Okay, so it was 5 red. Oh my God, I'm terrible at this. 3 blue, 2 green. How many total marbles are in this bag? Okay. So you're going to draw 2. And I want to find the probability of 2 red. Okay. So to do this the way I showed you, it's probably the first is red. And the second is red. Okay, so when you see the and statement, all right, what does the and statement imply? What mathematical operator? Okay, yep, multiply. So you just have to ask yourself this: are these independent or dependent events? So after I remove one red marble first, is it going to affect the occurrence that I draw a second red marble? Yeah, absolutely. Yeah, dependent. Okay, so it's just the probability. The first is red, but then times the probability the second is red, given that the first was red. Okay, but don't get bogged down in the formulas. Like, you just I showed you guys how to do this intuitively. All right, so how many red marbles are in the bag for the first one? Yep. And then the probability you draw a red marble then would be 5 out of 10. So if you remove a red marble from the bag, how many red marbles are left? Yeah, how many total marbles? Yep, so it would just be 5 over 10 times 4 over 9, which would be 20 over 90. So I'm sorry, I forgot who asked the question about homework number 6, but does that help? Does that make it a little bit clearer? Emmanuel, okay. Yep, so you can do the other problems exactly like that, okay? All right, so then let me just cover the last topics that are gonna be on the exam. Okay, there's counting methods. There's only going to be 3 rules I'm going to ask. It is the fundamental counting rule. Okay, that was that thing that was, I think the first example we did was the number of work outfits I have. Does that ring a bell? It was something, it's just like, you know, if you have a task you need to complete, a sequence of options, it's just N1 times N2 times N3 times how many ever there are. Then the other type of questions I'm going to ask are combinations and permutations. Okay, so just I did those examples to start class with, or excuse me, they were on your homework. I just did a couple like that. Then there's going to be an expected value question. There'll probably be 2 expected value questions. One where I'll just give you the table and you have to find the expected value. And then there's going to be an insurance problem. No factorial symbol. No, I'm not going to ask that. And then your last question will be the stuff we did today about the binomial probability distribution. Okay. I get good vibes. I think you'll all do great. I'll just turn my video on. Does anybody have any last minute questions they want to ask me? No questions, you guys will be all right? Okay, do the homework. I highly encourage you to look at the practice exam that I posted. So let me just show you where that is again. I'm gonna record it. I mean, it's already recorded. It'll take me 5 minutes, or it's gonna take me an hour or 2 to get it up there. Okay.
To find the sample space, do you always have to do the 3 thing?
For any sample space that I would ask you, that is an easy way to find it. Yes. I'm not going to ask you to find a big sample space, so no.
Okay.
So the recorded lecture, you know, I'm going to post it here. It just takes a while to render the video and then for it to load up to YouTube, because it's almost a 2-hour video, so it just takes some time. So I'll shoot you an email as soon as that's done. And then remember, under course content, well, I'm sorry I don't have the solutions. There's a sample exam here. here that you might want to look at, okay? I actually highly encourage you to look at it, okay? All right, I'm going to stop the recording.